Hey, this is Adam. I'm going to start uploading my engineering projects to YouTube for the next little while just so I can get a professional portfolio going. My first project that I'm going to do regards temperature, humidity, and just detecting the temperature in my apartment. My background is in chemical engineering, and so I don't have a ton of experience with electronics or programming. So I thought an old Arduino that I got from school might be a good place to start. For this project, I used a Arduino Nano with a RTC module, a temperature and humidity module, the DHT22, and then a SD card module. I hook this circuit up to a battery and then I let it gather temperature and humidity data over a couple days in my apartment to see the temperature difference between the downstairs and the upstairs. Mostly this is just a test to see if I was able to build this. And I also wanted to know what the difference is from downstairs to upstairs in regards to temperature. Because typically it's not very comfortable upstairs, but downstairs gets a little bit too cold. So I just wanted to see the actual difference and see the humidity level throughout the day. When I started this project, I started with the DHT11 temperature module, which is this one right here. The only issue with this module is the humidity has a very wide range. It's plus or minus 5%. The temperature is also plus or minus 2%. And that's an issue when you are dealing with temperature control or when you're comparing data for one reason. In order to understand that, you kind of need to know what a bell curve is. Most people would recognize this if they see it. I know that's kind of bad art. But this right here is a bell curve. What it represents is that 50% of the results of whatever test or process will be above this middle point and 50% will be below. When you are comparing two sets of data, you'll have two different bell curves. Where the means or the middle point of each of the data lies on different spots. However, if you have a temperature sensor like the DHT11 or isn't accurate enough or has too much variation, you won't really be able to tell what the temperature is. Let's say that the true temperature was around here. However, the range of that temperature could be anywhere from there to there because of the sensor. This means that when I am recording data, if the temperature is, say, 2 degrees different, 2 degrees Celsius, I won't be able to tell if the temperature data is the same or if it's different. For that very reason, I upgraded to the DHT22. This module is accurate to within, I think, a half a degree Celsius. So with that being said, that's why I upgraded to the new temperature and humidity module. Now I'm going to show you what the data turned out to look like. So this is the data that I collected on the first day when I was using the sensor that had a little bit higher variance than I wanted. You can see that the temperature kind of bounces around a lot. I'm pretty sure that that is the sensor itself, the accuracy of the sensor. You get pretty good humidity data on the upstairs humidity, but the downstairs humidity definitely bounces around a lot. I think it's just the difference in the manufacturer of each chip and the variance that they have there. So this right here, kind of like the stair-steppy, and then this right here, how it's all over the place. You can kind of tell that there is a little bit of a shift, but they're both around 25 degrees Celsius, and so you can't really tell what's going on in the data. So what I did after that, this is the data that I collected with the DHT22 sensor. You can really see that the temperature of upstairs is a lot higher than the temperature of downstairs. except for around the afternoon, it only differs by about a degree, which isn't too bad. On the humidity, something interesting that you notice, this right here on downstairs and this right here on upstairs, it was really humid in our apartment, and so I opened all of the windows and turned on a fan to try and get the humidity down to the outside humidity level, which is around 10% humidity. So I think our apartment doesn't really have a super great um, ventilation system, and so any humidity that we use just kind of gets stuck. This bump right here, so I take showers at night, and that is what that bump is. So as soon as I took a shower, you can see that there's a bump in the humidity, and then there's a slightly delayed bump in the humidity in the downstairs. It didn't really have that much of an effect on the temperature, but the humidity did go up a large amount, and then it didn't really go back down. In conclusion, by looking at the data, our apartment is still very uncomfortable humidity wise, and the temperature fluctuates a lot. But maybe in another video, I'll have to experiment with the different cooling techniques to see how we can get a hot, humid apartment to be a little bit cooler. The next project that I'm going to work on, there are some changes that I want to implement. Most of these changes will help me be more organized so that I don't have to spend as much time on things that I won't end up needing. For example, in this project, purchasing the DHT11 sensor ended up not being right for my purposes. I needed something that was a little bit more accurate in the first place. In order to fix this issue, the tool that I'm going to use is called a House of Quality. It's abbreviated HOQ. The House of Quality is a tool that helps you align customer requirements, technical requirements, and compare competitors with a product as well. I'm not going to be using the competitive comparison aspect of the House of Quality, but I am going to be comparing customer requirements with technical requirements. Essentially what I'm going to be doing is I list all of the customer requirements for the next project, or my requirements for the next project, including what the project has to accomplish. And then in the technical requirements section, which would be about like that, I would list all of the technical requirements and then the interactions between the technical requirements and the customer requirements. It's a little hard to grasp this topic when you don't have an actual example in front of you, and so in my next video I'm planning on building a House of Quality for the technical and customer requirements for that project. Thanks, and I'll see you next time.